Hi everyone. By this stage of our lesson today, you should be familiar with the observations that you would see if you reacted a group 1 metal with water. Now we're only interested in lithium, sodium and potassium at GCSE chemistry level and how they behave with water. So do they all float in water? Do they move on the surface of the water? Which ones might have a flame? What colour would the flame be? All observations like that. So you should have already completed that in your booklet using the videos. Now we're moving on and we're looking at page 110 where we're looking at the word, chemical and half equations for these reactions of alkali metals with water. So we're going to get started. So let's go on to the next slide now. You should remember that when we go to write an equation, even just a word equation, that we always need to start off with the general equations that we have learnt earlier in our chemistry unit. One of the equations that you were to learn was metal plus water will produce metal hydroxide and hydrogen. So whenever we take any metal, including these alkali metals, and we react them with water, we will always produce the metal hydroxide and the hydrogen. So for this first one that we're looking at, the first box at the top of the page, you will see that we're looking at the reaction of lithium with water. And you'll see lithium is a silvery metal there. And when we react it with water then, it will produce the hydroxide. So it will produce lithium hydroxide. So if you're going to write your word equation, remember all you do is you exchange the word metal for lithium in this case. And again, in metal hydroxide, we exchange the word metal for lithium. So instead of it reading metal plus water will produce metal hydroxide plus hydrogen, what we will have is we will have lithium plus water will produce lithium hydroxide plus hydrogen for this particular experiment. Word equations are handy enough. It's when we get on to the chemical equations that we seem to panic and we forget the rules. So remember, with a chemical equation or a symbol equation, what we simply do is we start with our word equation and we write down the symbols involved. So we look at this word equation and we see lithium first. So the symbol for lithium, using your periodic table, you should find is Li. And it should be handy enough to find. We're talking about group 1 metals, so we're looking in group 1. Water, you should know already as H2O. And if you don't know that, you need to learn that very quickly so you don't have to keep forgetting and having to remind yourself. Again, we've got lithium here, so it's simply Li. Hydroxide then. Hydroxide is one of those ones that you won't find on the periodic table itself. You will have to go onto the data leaflet at the back of the periodic table. And what you will find is remember, the two tables at the top of this, where we've got the ions, and this table on the right is where you will find hydroxide. And when you find hydroxide there, you will find that it is OH minus. And then finally, we have hydrogen. And again, hydrogen should be one that you know. You should know that it is always diatomic, so it doesn't exist alone. And it will be H2 then, if it's diatomic. So far, everything's okay, apart from this Li and the OH minus. We've got to figure out the formula for lithium hydroxide. So that's what we're going to do now. Looking at lithium and hydroxide here, the first thing, remember, when we're doing swap and drop, is that we need to find our valencies. So remember, the valency for lithium is just going to be the group number. So it's group number 1, so the valency is 1. For hydroxide, we can see the charge is 1 minus. So remember, to find valency in this case, just take off the minus, so it's also 1. As the saying goes, swap and drop. We swap and drop these, so we end up with Li1, but it's down low this time, OH1, and it's also in the subscript. We can simplify this then, just bring them together, remove your 1s, and we end up with LiOH. And that is our formula for lithium hydroxide. So we can put this whole thing together. So we end up Li for lithium plus H2O water, arrow LiOH plus H2. It's a lovely equation, but there's a problem. Hopefully you've spotted it. It's not balanced. So let's balance this equation. Remember, when we're balancing equations, some of you will be familiar with it. Some of you may not be so familiar. So just watch along if you're not. If you are, you could maybe work at this yourself. If you're not, I will give you the answer through working out. So the first thing when we need to balance the equations and we realize we don't have the same number of atoms on the left as we have on the right is we need to make a list of our elements underneath our arrow. So here I've done that. I've got Li for lithium, H for hydrogen, and O for oxygen. Now let's look at the left-hand side first. When you look at the left-hand side, you should realize we only have one lithium atom. So there we put a tally beside lithium. We've one lithium. On the left-hand side then, we have two hydrogens. So we've got two tallies beside H on the left, and then we have one oxygen, so one tally beside oxygen on the left. Looking at the right-hand side then, we again only have one lithium, so those currently are balanced. We then, looking at hydrogens, we've got one within our lithium hydroxide, and we've got two joined together. So we have got three hydrogens there, and then we have one oxygen. So we can see very clearly now that this is not balanced. So the first thing that I'm going to do then is I'm going to put a 2 in front of my lithium hydroxide. And I'm doing this because it's much easier to remove this odd number first. So let's remove this odd 3 hydrogens, and the easiest way to do is multiply that one by 2. So now what we have is we've got 2 lithiums, we've got a total of 4 hydrogens, and we've got 2 oxygens. And that's created quite a domino effect where nothing's balanced now. So we've got to go to the left-hand side and fix what I've done. So I'm going to start with lithium. I've got 2 on the right, 1 on the left. So if I multiply the left by 2, I'll also have 2 on the left, and they'll be balanced again. Looking at my hydrogens next, I've got 4 on the right, 2 on the left. So I need to multiply the left by 2 as well. So put a 2 in front of water, and that will give you a total of 4 hydrogens on the left. And it will also affect your oxygens. With our domino effect, we've also multiplied them by 2. And so unintentionally, by just trying to keep on top of things, we've actually balanced the equation. So this is your chemical equation that you now need to write down. The last thing then we've been asked for is the half equation. Now, a half equation is just looking at this lithium atom. We're looking at the thing in question, and we're seeing what happens to that individual atom. And what has happened here, as you can see in the diagram, is we've started off with a total of 3 electrons, 2 in the first shell, 1 in the outer shell. And like all group 1 atoms, when lithium reacts, it loses its outer electron. So we can see that it's lost its outer electron to enable it to have a full outer shell. So it now only has 1 shell. It's called the ion, and it's got a positive charge because we've lost that negative electron. So writing that in an equation, we start off with the atom. So we write Li, arrow, Li plus, that's the ion we formed, plus then the electron that we've lost. It's a way off to react with somebody else. So that is simply your half equation for lithium. What I want you to do now is I want you to finish the rest of this page. You have to write the word equation, chemical equation, and half equation for both sodium with water and then potassium with water. But remember, it follows the same process. They're from the same group, so they behave the same. So instead of writing metal plus water, remember we're going to substitute that for the name of the metal. So the next one you're looking at is sodium. So it's simply going to be sodium plus water gives you sodium hydroxide plus hydrogen. So you just have to write that down. Follow the same process then for chemical equations that I've used above, and then for the half equation. And the little exam cheat is that they all balance the same way. So that'll make your life a bit easier. So try that now and pause the video. You should have now completed page 110, and you should have written down your answers before you go any further, so you're able to check mine. Now, what's going to come up next is going to be the answers to this. So make sure you have done this first, and then you can mark and correct it using my answers, which are going to come up on the next slide. You were first of all asked for the reaction of sodium with water, so you had to write down the word equation first. So the word equation was simply sodium plus water produces sodium hydroxide plus hydrogen. You were then asked for the chemical equation, which is 2Na, be careful of your capitals, plus 2H2O, making sure that 2 inside the molecule is in subscript, arrow 2NaOH plus H2. And finally, you were asked for the half equation, which is Na arrow Na plus electron. Hopefully by now you have noticed that the chemical equation, well really the word equation, chemical equation and half equation, they're all the same. All you change is the metal each time. And this is the handy thing about groups. When metals are in the same group, all you have to do is change their name. Everything else remains the same. It shortens workload. Okay, so on to potassium with water. Looking at the reaction of potassium with water, the word equation then is potassium plus water produces potassium hydroxide and hydrogen. The chemical equation is 2K plus 2H2O, arrow 2KOH plus H2. And finally, the half equation is K, arrow K plus E minus. The final question on the page was more to do with your general knowledge, and this is one that you should know. It's usually a 2-mark question, and they ask you, what is the test for hydrogen gas? And this could come up anywhere in an exam, and it comes up in both year 11 and year 12, and sometimes even in A level, because it's such an important test. So what is the test for hydrogen gas? There's 2 points. You should make the 2 points. The first one is apply a lit splint for 1 mark. And the second is gas burns with a squeaky pop for 1 mark. Now that's all I wanted you to do in today's lesson. But essentially I'm setting you a little bit of homework before the next lesson. So what you need to do then is you need to answer the 6-mark question on page 111. Now if you look at page 107 and 108, they will help you with this. This is a question, this is a past paper question, and it's looking at how potassium is stored in the lab. So you're really looking at the safety precautions, how to manage the risks, what we have to do to that before we add it to water, and what happens to it at each stage. So you're thinking about what happens to the potassium when you take it out of the oil. Is it shiny? What happens if you cut a piece of it? Will that be shiny? Will it tarnish? So use those 2 pages in your notes to help you. Remember, the more you write, the more marks you get here, and 6 markers are great questions to bag your marks in. Okay, then I want you to read through the top half of page 112, where it talks about alkali metals reacting with chlorine. I want you to read the information about that, and then what I want you to do is answer the question in the speech bubble. So what you should be submitting to me in this assignment on Google Classroom is page 111 and 112. Should you choose that today, to do that today, that's fine. Or if you want to leave it and do it as homework, that is also fine, but it has to be done before our next lesson. Okay, read the instructions in the Google Classroom summary, and I will tell you when that will be. Take care now, folks. Any issues, give me a shout, but hopefully this will help you complete that bit of work.